Alright, ladies and gentlemen, here we are recording our portion of study on circuit diagrams. And a circuit diagram is just a picture or a circle diagram because circuits are all circles. And circuits, as we stated before, whoops, I went backwards, did not mean to do that. Circles have different elements. So if we come down and click on a pen, we have a voltage source, which are batteries. You have wires, which are conductors, and then resistors that are loads. And resistors are simply devices that take energy out of the battery and convert it into useful forms. This resistor will give off heat. So it might be in your toaster, toasting your toast, or in your electric blanket, keeping you nice and toasty. Or another type of resistor is a light bulb. And we'll draw a light bulb. It would look like that. It will give off energy, not in the infrared or heat, stuff like that. It will give off visible light. So we use symbols to represent these things. We don't draw pictures of resistors like we see here, or batteries like a door cell, and wires. We use symbols to draw pictures, and these pictures that we draw of circles or circuits are called schematics. So we're going to draw a simple circuit that contains a 9-volt battery. I'll just demonstrate so you can see what this process looks like, and then a 3-ohm resistor across its terminals. So we'll start off by drawing a battery, and when we do that, we usually draw one long line and one short one. The long one is positive terminal, the short one is negative, and then we have a conductor which goes up. And we're going to go through a resistor. I'm just going to make a light bulb for our resistor. And we bring it back home. If you prefer, we can label this 9 volts in, 3 ohms of resistance, and we're good to go. So we'll pull out this diagram. There we go. So it's a lot similar to what we just did. Let me see if I can move this out of the way. Or I'll make it a little bit smaller. Excuse me, so we can put these side by side. So again, current comes out of the positive terminal, up through the resistor, and then back home, and we have a complete circle. Very nice. Are there a couple ways you can add additional resistors into a circuit? If you look, these resistors, or these circuits, both have 2 resistors, R1 and R2, so you have 2 light bulbs. One way is to put them in a single line, so they're said to be in series. So if I draw, I don't know, I'm going to start off over here and go around this circle. I come up through the battery, and then I come down through the resistor. So these resistors all fall within that same yellow circle. Another way to do it is a parallel circuit. This has multiple paths. So I'll come up through the battery, and then I'm going to go up through R1 and back home. So that's one circle. Notice that this circle does not include R2. That has an independent path. So I'll just grab another color. We'll do it in a color that's not very contrasty. So I come up through the battery, and then down through R2 and back home. So we have 2 different circles. One is yellow and one is that pink color. And that means they have independent paths back to the batteries, and we're good. So all charges must move through both resistors to get to the negative terminal in the case of a series circle. And charges can have 2 ways to travel, either through R1, that top yellow path, or R2, that bottom pink path, but not both. So they have independent or multiple paths. So let's see if we can use this circle process in order to determine if these are a series or parallel. And remember, parallel will have multiple paths. So I'm going to follow this first one. I'm going to go up through the battery, and then I'm going down through this resistor, and I'll bring it back home. So there's one path. Ask yourself the question, is there another path that we could follow? Let's check it out. We'll start off right here. I'll come up through the battery, down through this resistor, and back home. So there's another path. Is that a series or a parallel circuit? Think about that. Multiple paths, parallel. Let's look at the second case. We'll start off here, Well, I'm going to go this way. I come up through the battery, down through R2, travel, 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 keep going, and then down through R1. I went through both resistors in a single path. That's a series circuit. So let's reveal this slide and see what they have to say. So we'll move our letters. The test is to trace the shortest route around the circuit. The resistors found on the same route are in series, and those are on different routes or in parallel. So again, we have different routes here, pink and yellow, so we have parallel, and then the same route, just yellow, series. Very nice. Total resistance of a circuit. So when we put multiple resistors in, these resistors impact how much charge can travel through a point in the wire every second, or it influences the current, and it's called Ohm's law. So how much current flows will depend on how much voltage is applied across these resistors and how much total resistance you have. Resistors and voltage from batteries determine the current. Circuits can be redrawn as if there were only a single resistor and battery. By reducing the circuit in this way, the circuit becomes easier to study. And the process of reducing resistors in a circuit is called finding its equivalent, or sometimes they'll call it the total resistance of the circuit. Let's go forward. So if we look at this, what happens to the circuit on the right? I'm going to reveal the answer for this one. Or what happens to the current in the circuit? So we have current traveling in this direction, we have current traveling in this direction, we have a current traveling in this direction, current traveling in this direction, and so on. Now ask yourself, in this case, how many paths are there? The answer is one continuous loop. So the current is said to be king in this, or the current in any location, anywhere within this circle is the same because there's only one path. So the current here, we'll call that I, would be the current there, maybe I1 in R1, and the current in R2 is I2. Now, let's put this away for a moment. What happens to the voltage in this circuit? And the answer is pretty easy. I'll try and explain. I said this before. When I travel this way, I go up through a battery, and then I continue to go. I travel, and then I come down through these resistors. And if I end up at the same spot, there's no displacement. So that means, just imagine you go up a hill and you come down hills. The sum of your ups is equal to the sum of your downs. If we refer to the voltage across R1 as V1, and we call that one V2, the sum of your ups, V of the battery, would be equal to the sum of your downs. So V equals V1 plus V2, and I everywhere is the same. So now sometimes when I teach this, I'll say in a series circuit, current is king. So we have rules. We know that the voltage of the battery, or what you put in, is the total of what you get out. Since voltage is IR, and the current is the same everywhere, the I's will cancel, and it gives us this new rule. The equivalent, or the total resistance, is the sum of the individual resistances. So the important equations right here and now is that voltage is the voltage up is the sum of the drops down, and the total resistance in series specifically is the sum of the individual resistors.